Now, I want to show you a very special conic, because most people think that this is an ellipse right away, but it ends up being a circle. Now, here's how you would first identify this. You would look at this and say, alright, that has a -4, that has a -4, it's in front of the x and y squared. That means it's an ellipse. Well, what you're going to find out is when you start solving for this, so let's add 4 to the other side, get rid of extra pieces. Now we have 4x squared minus 16x plus 4y squared minus 16y equals 4. Okay, we can't complete the square yet because the leading coefficients of both of those are 4. So what we do is complete the square twice after we factor out the value. So we're going to factor out a 4 here, and we're going to factor out a positive 4 here. This would leave inside x squared minus 4x. This would leave inside y squared minus 4y. It equals 4 so far. So cut this in half, square it, 4. But the reality is we're really adding 16 to this side of the equation. Cut this in half, square it, 4, same business. So sorry, I wrote it off the paper. Now, adding this all together, you're going to get 36. This will break down into 4x minus 2 squared plus 4y minus 2 squared. Here's how we know it's going to be a circle. Because these two numbers in the very, very, very front are the exact same number. So if you factor out the exact same number, you are guaranteed to have a circle. The only time you wouldn't have a circle is if one of them is minus. That's a hyperbola. So you would think, okay, so what do you do, Mr. Moya? Well, you're not allowed to have these numbers in front of circles. So you say, should we treat it like an ellipse? So should we divide by 36? In this special case scenario, the best way to approach this is to take this 4 and this 4 and get rid of them. So to get rid of them, you would simply divide by 4, and divide by 4, which would give you x minus 2 squared plus y minus 2 squared equals 9. That's your circle. So I wanted to put this on YouTube so you'd see a special case scenario that would look like an ellipse, but is actually a circle. Hope this helps.